In the previous video, I discussed multiplication, addition, and subtraction. In this video, I'm going to discuss division and the beginning of the perfect gas model. All right. So let's begin with division. So if I had 6 quantities and divide by 2, I would get 3 quantities. So what's actually happened? The 6 has been broken down into equal groups of 2. So again, I have 1 group of 2, 2 groups of 2, 3 groups of 2. So that's 2, 4, 6, which is what that is. So in a sense, the 6 is confined by the number 2, and confined in the sense that it's broken down into 2. An easy way to see this is with an example of books and shelves. If I had 6 books and I divided it into 3 shelves, then I'll get an answer that looks something like this. What's happened? Well, I've still got the 3 shelves, but now the 6 books are equally distributed among the shelves. Book 1, book 2 on this shelf, 2 books on this shelf, and 2 books on that shelf. And they all add up to 6. So the 6 books were equally distributed or confined into those 3 shelves. So, what is a force? We're coming back to the force because force is one of the most fundamental concepts in physics. We have 4 fundamental forces, and we'll come to those later. But forces explain a lot of things that happen around us, such as why do books fall to the floor if you let go of them, or why can't we fly, or why does the universe expand, or why does the atoms in the nucleus remain nucleus bound. Lots of things can be defined by force. So it's good to define what a force is. A force is a quantity that changes the motion of an object when it's not resisted. All right, so that's the definition of force. Mass, which is up there, is the amount of matter something contains, and acceleration is the capacity to gain or lose speed. Strictly speaking, it should be velocity, but for simplicity, we use speed. In the previous video, I discussed what multiplication does, and it allows you to interchange between actual physical phenomenon and the units that we create. For example, this object's accelerating by this arrow, but it could be rewritten as these smaller little objects being accelerated by these smaller little arrows. It just basically means that this mass has an acceleration, and this means the same thing. Each of these masses are accelerating by the same amount. So now we come on to the perfect gas. Now, the thing about forces is that it can be sometimes difficult to measure. In what sense? Well, if you have a closed container which has a gas inside, and let's say that it's been set to a pressure of 16 psi, then the question becomes, what's the force acting on the wall? Well, to answer that question, we would have to monitor every single gas molecule that's hitting the wall. And there will be millions, if not billions, of molecules hitting the wall and trying to change the motion of the wall. And you can see this if you increase the pressure of the gas until the container exploded. The change in motion would be in every direction. The gas would fly out in every direction. So it would have a blast radius, like a bomb. So we have to come up with a new property or a new quantity, and that would become pressure. So what is a pressure? Pressure is the force confined by an area, or the force confined by a surface. So as written there, force confined by the area. So what it also means is basically there's a particular force that's acting on an area. And how do we know it exists? Well, as I said, there's forces everywhere. So if I had a piston and I put it on top of a gas and there's nowhere for the gas to escape, that piston will remain floating or levitated in the air slightly. So, but gravity wants to pull that piston down. So there's a gravitational force that would love to, pull the piston down to the ground. So the question is, why doesn't it? And if you go back to the definition of a force, it's a quantity that changes the motion of an object. Unless it's resisted, there must be some resistance being given to this gravitational force. So that must be due to the pressure of the gas. The pressure acting on this piston keeps it from falling down.